So good morning all of you. In the last class, we have seen what is conditional probability. We have defined the conditional probability, and then towards the end of the previous session, we have written down or we have understood what is total probability theorem. This session begins with what is Bayes theorem. Bayes theorem in probability is a very important concept that you need to understand for understanding the random variable and its random process. Moreover, Bayes theorem, we have an algorithm called as Bayes algorithm for deep learning, artificial intelligence, and so on. So basically, probability is the foundation for all what you are going to do in future. So Bayes theorem states that the conditional probability of an event E of I to occur when A has already occurred is equal to the probability of EI, probability of A when EI has already occurred, into the sum of probabilities of E of J, where J is from 1 to n, all the possible sample space P E of J on the condition that A has already occurred. I am very sure that it is not very clear for you. As we do the problems, I believe that you can understand more about Bayes theorem. Okay. Now we'll define what is random variable. What are random variables? And we'll see some real-time examples of implementing Bayes theorem also. Bayes theorem is something that you might have already studied in your engineering mathematics previously. What are random variables? We'll define what is a random variable. A random variable is a rule or a relationship denoted by x that assigns a real number x of s to every point in the sample space. The definition for random variable: random variable is a relationship or a function or a rule where you are going to map every single point in the sample space, every single point in the sample space to a real number. In the next slide, I will teach you this with the diagrammatic explanation, which makes it much more clearer. A real valued random variable x is a function that maps each outcome in the sample space omega of a probabilistic experiment to a real number x of omega, which is termed the realization of the random variable in the experiment. So a random variable is neither random nor variable. Am I right? How many of you agree with me? A random variable is only a function. A random variable is a function which connects to the real number line, or for each point in the sample space. Shall I go to next? So this is what we mean by a random variable. This omega 3, omega 1, omega 2 are all points in the sample space, and this x of omega 3, x of omega 2, x of omega 4 are all the random variables that is mapping each and every point in the sample space to the real number r here. You can see that. So, random variables are denoted by capital letters X, Y, and so on. We have to follow certain nomenclature. Only then others can understand what you have written. Okay. In general, all random variables are denoted by capital letters, capital X, capital Y, etc. Individual values of random variables are defined as the function of particular point in the sample space. A random variable is discrete if the range of its values is either finite or countably infinite. This range is usually denoted by set of x of j or I. We usually use capital letters to denote random variables, and a discrete random variable is something where you have the range of its values to be finite or countably infinite. As we go on in this lecture, I will tell you what is meant by countably infinite. So let us see what is meant by discrete random variable. Consider a case you are tossing a coin for one time. Sample space will consist of only two values, either 0 or 1. Let us consider success to be something when a head falls. We are doing a random experiment. We are tossing a coin. The set of sample space consists of two values, head and tail. Let us consider even, or the probability of even, to be a head falling. So when we are mapping this to a random variable, we'll map it to 0 and 1. And this is how we map random variables for a discrete set of values. So let us look into another example where we are mapping this to a real number. This is an experiment where we are throwing a dice, the possible number of outcomes. We are mapping it to a real number. Listen here carefully. 1 by 36, possibility of getting 2 when a die is thrown. Right? A die is thrown 2 times. The possibility of getting both the die values to be 1 is 1 by 36. And we have mapped this to a real line. Okay? The function that gives 1 by 36 takes input as 1 by 36 and maps it to 2 is called as the random variable. A random variable x is neither a variable nor random actually. So a random variable x is not a variable but a mapping function that assigns to each point in the sample space omega a real number x of omega on the real line. A function whose domain is a sample space and whose range is a set of real numbers is called the random variable of the experiment. Explain what you have understood by a random variable. So random variable is a function. The input for this function, the values which the function depends upon is the points in the sample space. So the range of the values that a random variable can take is all the values within the sample space, and the outcome will be its mapping in the real line. All our processing, all our future sessions will be based on random variables. Random variables could be discrete, maybe discrete and take only a finite number of values, such as the experiment we have seen, coin tossing, etc. Random variables can also be continuous, can take a values from a range. It can be continuous, it can be large. So what is a discrete random variable? What is a continuous random variable? We'll be studying both these things in detail in the coming lessons. And these are very important points, and you need to use so much of your understanding to find out whether a random variable is discrete or continuous, or what are the processes that can be done with discrete variables and continuous variables. The random variable that represents the amplitude of a noise voltage at a particular instant in time is the example for a continuous random variable, because it may take any value at any point of time. So listen here, it means that the example for a continuous random variable, you can take a voice signal, what we'll be processing very commonly. Explain what is discrete and continuous random variable with necessary examples. If a question appears, you need to write answers with examples. So the next part is CDF and PDF, cumulative distribution function and probability distribution function. What is meant by CDF and what is PDF? Probability distribution function. In this class, we will be understanding what is cumulative distribution function, and in the next class, we'll see the properties of CDF, and we'll be trying to understand what is probability density function. So let us consider a random variable capital X. The cumulative distribution function, or CDF, is defined as fx of x, fx of x, which is the probability that omega, small omega, is an element of the sample space capital Omega, and x of omega, the random variable x of omega, is something that is less than small x. So these are the two important things that you have to remember. Fx of x is the probability that this falls, the random variable falls below the value of x. Cumulative distribution function is defined as the probability of the random variable that falls below the value of a particular point, that is denoted by x. When we see some examples, you will be able to understand and you will be able to map, you will be able to do problems in cumulative distribution function. You should be able to do problems. Fx of x is equal to P of x less than x. So let us define cumulative distribution function or probability distribution function. CDF or PDF is a description of the probabilistic behavior of a random variable, and that is why it is very important. The probability that the outcome of a random experiment takes a value that is less than or equal to x on a real line is given by the cumulative distribution function. Okay, the chances that the outcome of a random variable can take any value which is less than a particular point where x is equal to capital X is equal to small x. Yes, this capital X is equal to small x, or it comes less than that. That is determined by what is called as cumulative distribution function. CDF of a random variable. So we'll be studying all the properties of CDF. The first property of a cumulative distribution function is that the least value it can take is 0 and the maximum value is 1. Fx of x lies between 0 and 1. So thank you all. Thank you for listening to me. The second property onwards will start in the next session.